When you're building a machine learning system, one of the biggest choices an architect has to make right out of the gate is this: to supervise or not to supervise. And it's a call that can make or break a whole project. So today, we're going to break down how to get it right.
You know, it all boils down to this one big question. How do we actually teach a machine to think for itself, to find patterns and make smart decisions? And really, the answer all comes down to one thing. What kind of data are you feeding it?
So this really breaks it down perfectly, right? On one hand, you've got supervised learning. Think of it like studying with flashcards. You've got the question and bam, the answer's right there on the back. The model just learns to connect the dots. But then there's unsupervised learning. That's more like someone hands you a giant box of old photos and just says, go sort these. There are no instructions, no right answers. You've got to find the patterns and create the groups all on your own.
All right, so here's what we're going to cover. First, we'll dig into that big difference, learning with or without the answers. Then, we'll talk about how you make the right choice for your project. We'll also look at some amazing real-world examples where unsupervised learning got huge results. And finally, we'll explore a powerful hybrid approach that gives you the best of both worlds.
Okay, let's jump right in. What really, at its core, separates these two ways of learning?
So, supervised learning. It's all about one thing, and that's prediction. You're basically feeding the model a bunch of data that already has labels. Think of it like customer profiles that are clearly marked churned or stayed. The model's whole job is to figure out the connection so it can accurately predict what new customers are going to do.
Now, unsupervised learning, that's a whole different beast. It's all about discovery. You're handing it raw, unlabeled data. Its mission isn't to hit a specific target you've set. Nope. It's to just explore. To dig into the data and find patterns and structures you didn't even know were there.
Okay, so how do you actually choose between them? How does an architect make that call? And this isn't just some textbook problem, right? This decision has huge consequences for a project's budget, its timeline, and whether it succeeds at all.
This table lays it all out, super clear. On the supervised side, you absolutely need high-quality labels for prediction. But with unsupervised, no labels needed, because the goal is discovery. And look at that cost row. That's a big one. Labeling data for supervised learning can get super expensive, which makes the low-prep world of unsupervised learning look pretty tempting. So let's put on our architect hat for a second. These are the questions you're constantly asking yourself. First off, do we even have labeled data? What's our goal here? Are we trying to predict something specific, or are we just exploring to find something new? And what about resources? Do we have the time and the money to label everything? Sometimes, for compliance reasons, you absolutely need that traceable prediction you get from supervised models. But hey, if you're just swimming in a sea of unlabeled data, unsupervised is often the only way to even get started.
Okay, this is where it gets really cool. What happens when you just lean into that messy, unlabeled data? Well, sometimes that's where you find the biggest breakthroughs.
All right, check out this number, 85%. What in the world could that be? Well, a telecom company hit an incredible 85% accuracy in flagging high-risk customers who were about to churn. And here's the kicker. They did it by finding new churn patterns that had no labels. A supervised model would have completely missed these because it can only see what it's been explicitly taught to look for.
Okay, next up, 34%. This one comes from the world of finance.
A credit union managed to slash its fraud losses by 34%. That's huge. And how they did it is really interesting. See, their old way of labeling fraud was always slow and incomplete. It was always a step behind. By using unsupervised clustering, they found totally new fraud patterns, things like weird spikes in transactions right around lunchtime, stuff that the human analysts had been missing for years.
All right, one more for you, 28%. And this one is all about customer retention.
The key here isn't just the number, it's how they got there. An online subscription service boosted their retention by 28%, and they did it by using clustering to see how people were actually using their service. This is what let them discover a whole new group of customers they didn't even know existed, the binge watchers. And that's the whole point, isn't it? You can't train a supervised model to find a customer segment that you don't even know is out there. That is the raw power of unsupervised discovery.
But here's the thing. What if you don't actually have to choose one or the other? Some of the smartest teams out there are now blending these two methods. They're using the discovery power of unsupervised learning to make their supervised models even better.
And the workflow is actually pretty straightforward and honestly, kind of brilliant. First, you start with all that messy, unlabeled data.
Then you run an unsupervised model, say k-means, to group it into natural clusters. And now for the magic trick, you take the ID from each cluster, which group each data point fell into, and you treat that ID as a brand new piece of information, a new feature. Finally, you feed all of that, the original data plus the new cluster feature, into a supervised model. You're basically letting Discovery make your predictions way smarter.
So, which supervised models are the all-stars for this kind of hybrid job? Well, heavy hitters like XGBoost are a top choice because they're amazing at learning from these new cluster features. Random Forest is another great option since it's really good at handling any noise or imperfections from that first clustering step. And if you're dealing with a mountain of data, something like LightGBM is going to give you the speed you need.
And we're not talking about a small improvement here. Just by swapping out a simple model for a beast like XGBoost after you've done your clustering, you can see a 5 to 15% jump in accuracy. That is a massive gain.
Okay, last step. To really squeeze every last drop of performance out of your new hybrid model, you've got to tune it. You've basically got two main tools. First, there's Grid Search CV. Think of it as the tortoise. It's slow and methodical, testing every single possible combination to guarantee it finds the absolute best one. Then you have Randomized Search CV. This is the hare. It's way faster, like 5 to 10 times faster, because it randomly samples the combinations. And the crazy thing is, it almost always finds a result that's just as good as the slow and steady approach.
So here's the pro tip, the rule of thumb you can take with you. If you have more than 5 parameters to tune, and let's be honest, you usually do, just start with randomized search. Don't even think about grid search. You're going to save yourself a ton of time and get a fantastic result.
Now this entire breakdown, from the basic ideas to these advanced hybrid models, is all based on solid research and real-world results, with insights pulled from sources like Perplexity.
So, I'll leave you with this question. The next time you're faced with a giant pile of messy, unlabeled data, is it a roadblock or is it actually an opportunity?